Hello, I hope you're doing well. In this video, we're going to review one of the applications of non-serial dynamic programming in solving integer linear programming problems. In this section, we'll use an example to explain the application of non-serial dynamic programming. Our example consists of an integer programming model with a specific objective function and constraints. Also, our variables are binary, meaning they can only take values of 0 or 1. Before taking any action, we draw the model as a graph. Each node represents a variable, and the arcs, edges, show the connections between the variables. So how exactly does our solution method work? Our goal is to eliminate variables one by one until only one variable remains. Then, using the value of that remaining variable and working backward, the backward method, we calculate the optimal values of the other variables and the objective function. Let me put it another way so you don't get confused. For example, if you look closely at the graph, you'll see that x1 is connected to x2 and x3. So we define a function called h. The purpose of this function is to determine the value of x1 based on the values of x2 and x3. By doing this, we effectively eliminate x1 from the equation while still preserving its effect on the objective function. At the beginning of step 1, we decide to start with variable x1 and eliminate it first. To do this, we define the function h1. Another point, choosing which variable to start with is up to you, but keep in mind that the variable you choose must be connected to at least one other variable. By connected, I mean there must be an arc in the graph linking them. Next, we calculate the values of the variables and the value of function, h1. Now we are at the end of step 1. We've reached the conclusion that by having the values of x2 and x3, we can determine the value of x1. So it's time to remove x1 from the model and graph and update them. In step 2, we proceed just like in the previous step. We choose variable x5 for elimination, and the variable connected to it is x2. Finally, we define function h2 and calculate the necessary values. At the end of step 2, we also update our model and graph. In step 3, variables x2 and x4 are selected as candidates for elimination, and the variable connected to them is x3. The subsequent calculations follow the same pattern as before. In this section, the calculations are explained in detail. At the end of step 3, we update our model and graph again. In step 4, variables x6 and x7 are selected as candidates for elimination, and the variable connected to them is x3. At the end of step 4, we update our model and graph once more. As you can see, only variable x3 remains. Finally, only one variable is left, and the objective function depends solely on variable x3. Next, we calculate the optimal value of x3 and the objective function. Now that we have the optimal value of x3, as we mentioned earlier, we use the backward method to calculate the values of the other variables. I hope you found this information useful.